One of the easiest things, perhaps, to do in Fusion 360 or any modeling software is to create drawing sheets out of the parts or the models that you've already drawn. The interesting problem comes when you take the drawing sheets and give them dimensions and tolerances and the bill of materials. So in this section, we'll see how to convert a model to a drawing sheet. That is a 2D representation of a 3D model, because quite simply because the 3D viewer will not be available with every manufacturer, and also because drawing sheets are the universal language of understanding of understanding a given product. Moreover, the drawing sheets are more like a legal document between a designer and a manufacturer. Should something go wrong in the part, it is always a drawing sheet that is referred to see on whose end is the mistake. Did the manufacturer read the designs correctly, or did the designer give the detailing, the tolerances, the constraints correctly? So let's get started on drawing sheets and bill of materials. I'm going to use this utility knife to create a drawing of the utility knife. Since we have a nice assembly already ready with Fusion 360, you will be using this feature, the drawing sheet feature, to make projected views on your drawing sheet from of the problem statement of the product you make in the problem statement. So the first thing you do is you go to the workspace, you change the workspace from design to drawing, and you're going to create a drawing from this design. So choose this, choose what you want to show, just the visible assembly or the full assembly. Go to create new. You could either have your own template if you already have it stored over in the cloud, or you could start from scratch. Now, if you go with ISME, then the sheet size will vary. If you go with ISO, there'll be different sheet sizes. So I'm going to take ISO and take A3 sheets. The industry common is A3 sheets are an equivalent of that. You might have to find an equivalent for that in ASME and click OK. Now here we see that a piece has come with us from the previous design, and when you zoom in, you see that is nothing but your knife. You would see over here you have the base view, projected view, section views, detailed views. Now, what exactly are these views? If you go back to your utility knife and click on, say, the home, you see that this has some original way to look at it. There's a home view to look at it. If I click on the right, I can see what the right hand side looks like. Go ahead and click the top. I see that there are just certain parts in the top that are visible. And then there is the side. But you do realize that in spite of having 8 different sides, three sides, three top, left or right, and bottom, three sides are more than enough to, to uniquely and completely describe the details of the knife. I'll probably choose the right plane. I'll go with the top plane for the general nature of the curve, and probably and the front plane. Now, in this case, the front plane is not very meaningful, so probably I'll take the bottom plane. So this is exactly what will happen in your drawing as well. So go ahead and let's do it again. Uh, so I'm gonna go ahead and design, drawing, from design, home it first, always home it, drawing, from design, go slow. So here is your drawing. See, I'm gonna need the base view. This is my base view. Once my base view is done, I'll take the projected view. Now, now this was my top view. This, as per this, is the front view. When I take it here, you can see this is the side view. And if I want to show a more isometric view, I can show it in different, I can angle it in different ways, and you see that the shape changes. So the usual nomenclature is you have the side view and the top view at the top. So you have either the front, top and side, or you have the top, front, and side, depending on the kind of projections you use. But for now, you just have to give three distinct views. That's all that matters. And if you want, additionally, an isometric view. If you want to go ahead and show some uh, details in your drawing, just going to remove this. If you want to go ahead and show some details in your drawing, or you might want to increase the shape of size of it, you could do that from here. So they are equally big. So I'm going to make them true to, if you want to make them true scale, 1 is to 2 is half, 50%. I'm going to make them to their true scale. You could just click on individually of these and rescale them. It's a bit bigger than we want it to be. Could hold it in a place and move the object. If you're changing the scale for every object, you might have to mention that. So I'm not moving this or changing this because I took the true scale and also because there's not enough space, but preferably keep all four of these in the same scale. If they're 1 is to 1, keep them 1 is to 1. If they're 1 is to 2, keep them 1 is to 2. Do not change the dimensions. The next thing would be, if you want to show you want to show these notches like really detailed, you can click on something called as detailed view. Click on a component and kind of draw it out. And here you will see what that component exactly looks like. So it removed this notch completely and it showed how it looks. Let me see if I can change the style for it. Yeah. Alternatively, if you want to see how it looks in a sectional view, I want to choose a parent view and see what kind of section you want to take. Suppose I want to take section from there to say here to here. That is the cutting line, the section that's where the section is going to be cut, as you can see. Take the section, cut the line, and you will see a section view. The next thing you might want to do is add dimensions. So you can give different types of dimension: angular, straight, ordinate. Again, the command for that is D as well. Suppose just click between the 2 points where you want to give the dimensions. Do not give redundant dimensions. This is a more curvy for more curvature objects. Be sure to give the radii. Be sure to give the end to end distances in the object and stuff like that. The second part of this, you can also create a sketch within this, add your own geometry, make changes to the model in the drawing, although it is strongly not recommended that you do that. The second part of this, more important part of this was the bill of materials. To create a bill of material is nothing but a list of every other part inside your model. So if it's a lamp, then I'm going to go back to the lamp example. If it's the lamp, it is going to be when you draw the when you assemble it and you draw the drawing sheet, it's going to be uh, lamp shade, lamp holder, the central shaft, the lamp base, wires. All these things have to be mentioned as a list of parts. What material was used and how many of these parts are there? Have you used any screws and bolts and fasteners to put them in place? Are there any joints that you need to know? Now, all these things, just go to table and say I don't have space. I'm just going to click it here. You'll notice as soon as I click on the table, since this part has all of these named in our model, you will see that these details come in directly. If you remove that, if you want to make changes to this, now this shows the number of items, quantity, part number, etc. If there had been space here, if it blurs to the top, this would have the item and stuff would have been at the top. It would have been a normal table. Just if you want to make some changes, double click on it. You can add the part name, you can add the mass, you can go on making those changes. Now For a part that doesn't have these details, suppose we take, okay, let us take the example of our inner cylinder and say I want to make a drawing out of this, all right? So, I converted that to a drawing. Now I have, say, front view, a top view. Now there isn't a lot to do in the side view, so I took the isometric view and I took out a section. Section views, as I showed you previously, it's just click on the parent object, suppose draw a line from here to here, hit enter, there is your section. So it's showing like a cross section, it's showing like an oblique line cut. These lines are nothing but a section. It's about this line that's going to part and it's going to show the object to you. Anyway, and then I go ahead and add some dimensions. The primitive dimensions are here, so I'm going to go with this. Yeah, it can be a bit annoying for tinier objects to dimension them, so be sure to zoom them in and kind of play a bit with the control interfaces. Now, once they're dimensioned, I'm going to add a table again. Now, I had them named as component 1 and component 2, so there isn't much I could do over there. And the material by default was steel. If you wanted to go ahead and change these, then you go here, you change the name, click on it and say cylinder 1, all right? And you want to change the material, go to modify, physical material, and you have a library of materials to choose from. I'm going to go to metal. I'm going to go with aluminum. For this one, drag and drop, as simple as that. Now it knows the material. And now when you come back to the drawing sheet, interesting, where is the drawing sheet? I'm going to close a little unnecessary ones, but we just have the necessary ones. So now when I create a drawing sheet, now that one has already been created, so it will not record the changes. So now when I create a drawing sheet, and I place these objects and I give them their projected views, an isometric view, side view if you want, and then maybe there's no details to show over here, so I'm going to give sectional view. Okay, and now when I go and try to insert the table, it has component 1, cylinder 1 and component 1 and aluminum. So these things changed. You can also add the mass of the object. It calculates depending on the dimensions and the material density of aluminum. You can add a part name to it. You can remove some of these items. So this is how a bill of material is made. Now this bill of material, you can also use something called as balloons. And take a part, balloon it out, and then show the numbering of the part number over here. In addition to this, this table has all the details of your drawing. Imagine you're in a car manufacturing company and you have so many details to talk about in your drawing. What version it is, what part are you changing, what version is it, what modifications have you made. Now, how am I going to know the difference between 11 different CAD models, all looking seemingly similar, but with mild variations or a version improvement? That's when the title, created by whom, the type of document, technical reference, all of these questions come into picture. Date of issue, again, very important. If I don't know on what day the drawing was created, I might as well not be able to arrange them in chronological. Which part of the sheet is? Right now, we have been looking at very simple components, just like one sheet, or don't require one whole sheet. But as the complexity of the part increases, you might need multiple sheets. Next, to get an output, click on PDF, output as PDF, current sheets or all sheets. Um, okay, and there you go, your PDF is saved. I'm just going to save it as test, save on my desktop. Save. So now you have your PDF file that can be that you can share with the manufacturer. That was all about drawing sheets. I realize it's a slightly lengthy video, but that was to show all the possibilities that a drawing sheet can do. So you could stop and fast forward as and when you want throughout the video to kind of understand and re-understand the concepts. Have a good one. Thank you.